And now we're going to finish Chapter 1, Section 1. So we're going to be looking at equation solving. Last time we looked at modeling. Today we're going to be looking at equation solving. So before we jump right into solving equations, one of the most common things we use to solve equations algebraically is the zero factor property, which says when the product of two or more factors is zero, then at least one of those factors must equal zero. So for example, if you had ABC is equal to 0, then either A is 0, or B is 0, or C is equal to 0. So let's look at this first example here. Solve 2x cubed plus x squared minus 13x, not minus, equals 13x minus 6 over the real numbers. So I think most of us know the first step in solving this is to get everything on one side, right? So if I were to subtract 13x and add 6 to both sides, right? 2x cubed minus x squared minus 13x plus 6 equals 0. And now the goal is to factor it, right? We want to go whoosh, 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 swoosh at least, right? And something, if you aren't allowed to have a calculator, one of the quickest ways to do that is to remember the factor theorem, right? Which says if you set this polynomial and think of it like a function and plug values into that function, any value you plug in, if it is equal to 0, then that's one of the roots. So x minus that value a is a factor. So again, if you see the 6 here and the 2 here, you can think about all possible ratios of factors of 6 divided by factors of 2. Hopefully that sounds familiar from Algebra 2. If not, come see me during office hours and we can review these things. But factors of 6 divided by factors of 2, it could be 1, 3, 6, 2, a half, 3 halves. Anyway, I just started trying. So f of 1 is -4. Nope. But f of 2, when you plug 2 in here, it works. So I know this is going to be x minus 2 times something. So how do we factor the rest? You could do long division. You could do synthetic division. I wouldn't do either of those. I would just kind of guess and check in the following way. X times what will be 2x cubed? Well, it's going to have to be 2x squared. These two give me 2x cubed. When I multiply these, I get a -4x squared. I want a positive x squared. So what do I need to get a positive x squared? Well, I'm going to need a positive 5x squared, which means x times this next thing had better be positive 5x. X times 5x gives me that 5x squared. So I end up with the positive x squared that I need here in this term. But again, I now have -2 times 5x is a -10x. And I want a -13x. So x times what here will give me what I need so that I end up with -13x. Well, I need -3x. So if I take x times -3, that's going to give me this term. And lo and behold, -2 times -3 is positive 6. And that is how it factors. So then I've got this quadratic 2x squared plus 5x minus 3, which I can then factor, right? I mean, I wrote it over here, but again, so you can see my thought process, 2x squared, only way to get that is to get 2x and x. 3 is going to be 3 and 1, and it's negative, so there's going to be opposite signs. So when I think about putting 3 here or 3 here, well, if I put 3 here, 3 times 2 is 6. If I put 1 here, that's 1. From 6 and 1, can I get a 5? Yeah, if I do a positive 6 and a -1, that'll give me a positive 5 and -3, and that's how it factors. So set each of these factors equal to 0, because our original problem was, or not even our original problem, but once we set everything equal to 0, we're looking for the roots, the zeros, and solve, and you have x as a half, 2, or -3. So go ahead and pause this video right now, and you try. Solve this problem over the real numbers without a calculator. All right, now that you've done this, go ahead and check your work. Again, get everything on one side set the whole thing equal to 0, factor out your x that you have in common, factor the quadratic, set HPC equal to 0, and you should have 3 solutions. The most common mistake students will make with this is they'll try to divide everything by x to simplify instead of factoring it out. When you do that, not only is it wrong because you lose out on a solution, but it's also wrong because, again, if x equals 0, are you allowed to divide by 0? No, it's algebraically unsound. So let's review solving radical equations. How do we solve a radical equation algebraically? So the things you have to look out for radicals are extraneous solutions. So what's the strategy? First, isolate the radical, so I subtract 2. Then square both sides. All right, so -2, then square both sides. And x minus 2 squared, that's going to give me x squared minus 4x plus 4. That squared is just 2x minus 1. Again, set everything equal to 0, so I'm going to subtract 2x and add 1 to both sides, and that's going to give me x squared minus 6x plus 5, which factors very nicely, and I end up with 2 positive potential solutions. They are only potential at the moment because they may or may not actually be true solutions of our original equation right here. So we go back and we check. So if x equals 5, we plug 5 in. 10 minus 1 is 9. Square root of 9 is 3. 3 plus 2 is 5. Yes, check. 5 is the solution. But if you plug in 1, 2 minus 1 is 1 plus 2. The square root of 1 is 1 plus 2. That's 3. Equaling x, that's not equal to 3, right, if x is 1. So 1 is extraneous. It's not actually a solution. And in this case, there is one and only one solution, which I was going to circle right there. All right, so that's a little bit of review solving algebraically. We can also use a graphing utility to help us solve equations. So your TI inspires is what we're talking about here. Let me scroll on down. So let's look at this example here. If I asked you to solve the equation to the absolute value, let me scoot up just a smidge. The absolute value of 2x minus 4 is equal to 2 times the square root of 3x minus 2 graphically and algebraically, right? Algebraically, if that looks a little intimidating, yeah, that's okay. We'll review it. Graphically, not too bad, but there's 2 approaches to solve these types of equations graphically. The first option is set everything equal to 0, right? And let this whole expression be a function. So again, if you're using your TI inspire, you're going to type ASB to get the absolute value notation here. So go ahead and let F1 be the absolute value of 2x minus 4 minus 2 square root of 3x minus 2. When this function is equal to 0, right, f1 equals 0 means you're looking for the x-intercepts. And based on our graph, 1, 2, 3, 4, 5, and 6 are our 2 solutions. The other option is to let this be function 1 or function 2, and let this be function 3, right, and set those 2 equal to each other, and basically try and figure out where the graphs intersect. So this really should be f2 and f3, just so I'm not using the same function name, but in my calculator that's what I had. So let f2 be the absolute value function, let f3 be the radical function, and setting them equal means you're trying to find where they intersect, and again, that's going to be at 1, 2, 3, 4, 5, 6, right, when x equals 1 and x equals 6. Algebraically, you just have to remember that the absolute value of something, if you remember, the absolute value of x is equal to 3. Well, that meant that x could equal 3 or x could equal -3, right? I'm going to write that negative x equals 3, right? Either positive this is 3 or negative this is 3. If negative x is 3, then that means x is -3, right? So it's the same thing if we're dealing with expressions. So if you start with this equation, to solve it algebraically, take the positive version of this, which is just 2x minus 4, equals that radical, or now take the negative version of this, negative 2x plus 4. And again, when I say positive version, I literally mean positive that expression, which you don't even have to write, right? You can just write it as 2x minus 4. And now both of these look very similar to the radical equation that we practiced on above. So go ahead, pause the recording, and see if you can work these out yourself. All right, assuming you've done this on your own, here are my solutions. In both of these, you actually end up with the same two solutions, 6 or 1, and when you check, they both work out, so that you have two solutions. Exactly what you would expect, because based on the graphs, right, you have two solutions. So if you want, you can go ahead and pause and double check my work. Here, I squared both sides first. The thing that's different in this example than the previous one is make sure you square that 2, so you get 4 times quantity, 3x minus 2, distribute, move everything over to one side. The fact that you could factor out a 4, this means I could have divided everything by 4 earlier. You can always divide everything by a constant. Not a variable, but a constant, yes. And that's actually what I did over here. I decided, hey, right off the bat, if I distribute that negative, let's divide everything by 2 to just simplify that away, and then I don't have this coefficient here when I square both sides. Same, but different, right? And they both check out. So let's continue our discussion, and let's now look at some other ones. If I asked you to solve the absolute value of 3x minus 1 is equal to 12 minus the absolute value of 2x minus 2. Here I didn't specifically tell you how to solve, so I'm going to say let's go graphical as opposed to algebraic. And so again, subtract 12, add the absolute value of 2x minus 2, set that equal to 0, call that a function, right? In my calculator, I called it f3. And again, we're looking for the zeros. So go ahead and zoom in. And so here's 0. There's 1, 2, 3. It definitely looks like it has 3 as a solution. And then how do you know that it's negative 9/5? So to harness the full power of your calculator, right, I went ahead and I used the 0 function, the 0 operation, right? So if you hit menu, algebra, zeros, type in the function name with the argument, right, comma, and then the expression, and then it'll tell you exactly what it is. So this is where you're reaching some of the pitfalls, right? Just by looking, it's not always clear and easy to tell what's what. So let me toggle back over to our blank version, right? Similarly, right, if we look over here, solve 2x minus 4 equals x cubed plus 2x squared minus 5x minus 6. So again, I don't really want to try to factor that algebraically. I mean, I'm totally fine saying minus 2x plus 4 minus 2x plus 4 gives me x cubed, right? So sorry, gives me 0 is equal to x cubed plus 2x squared minus 7x minus 2, right? And so again, let that equal a function in your graph it. And there's different ways you can get to the zeros. You don't have to use the algebra screen. If you use the algebra functions on your calculator screen, you'll get the precise values, right? The fact that it has a 2, we could have then factored 2, right? We could have factored and said this is x minus 2 and did that again, so that would have been x squared. And then negative 2x, I would need a plus 4x to give me a 4x squared minus 2x squared gives me a positive 2. And then that's a negative 8x, so I would need a plus 1 to give me a negative 7x, negative 2 and 1. And then x squared plus 4x plus 1, that does not factor, and that's where these radicals are coming in, right? This guy is going to give me x is equal to, well, negative rad 3 minus 2 and negative rad 3 plus 2. So I'm not going to take the time to do that here. Or decimal approximation is what you would get if you trace the zeros to find the zeros on your graphing screen here. So why would we use a graph? Because it helps give us an idea of where the zeros are and what they might look like. Now, sometimes a graphing utility can mislead a casual observer, so be warned. For instance, if you look at this guy, it looks like there's only one solution, but in fact, when we zoom in, there are no solutions right there. There's only 1 0. This never actually crosses the line. So go ahead and you try. You try on your own doing this now. And here in this case, when you graph it on your calculator and you zoom in, you see it actually intersects twice. So we've got 1, 2, 3 solutions